Okay, so I'm at this position where there's a problem with lines at an angle, at any rate, it seems. Let me just run this and see what I was getting. Right, this worked alright. This started to have a problem. I bet this is going to crash it. That didn't crash it. That... have another go. Well, that actually worked sort of alright. Oops. It's making an error at times though. That worked alright as well. I have a feeling it's okay. I'm just going to keep on going with this. Well, that's completely wrong. It seemed to get the one that went off the side right. The one that went off. Can it get one that comes... one that goes off the bottom? Also, I don't know how reliable my sort of back to, like I'm not necessarily concentrating on which is the start and which is the end of the line. I even seem to get that right. It only, is it? And so is it all things that go off the sides? Yes, I mean this looks more or less right. I have a feeling that my rounding, I might still have to work on my rounding. I might see what a larger scale experiment looks like before I concern myself too much with rounding. I think I've got a problem with whatever it is that goes off the bottom of the screen, because even if I start on the screen and go off the bottom, it just loses it. Any situation that involves going off the bottom, that's not right. That's not right. It's quite funny in a way, seeing what it thinks might be happening. But then, the second it's not going off the bottom, seems right. So, where do I decide? This line is at an angle with at least one end off screen. Yeah. Check left, check right, check top, check bottom. X at Y height equals X at Y height equals object output height minus Y at x0 divided by gradient. Am I getting that bit wrong? I can easily believe I am. Can I be bothered drawing something out? I'm probably going to have to. Y equals, yeah, I'm just going to write it out. I'm just going to. And it's not very hard, is it? Y equals mx plus c, and I'm solving here for x. So I subtract c from both sides. Is this right? I can never remember. Then divide throughout by m y minus c divided by m. Now to me that looks like it should be right, and that is the same. 0 minus c y at x0 divided by gradient. If x at y height is greater than 0 and x at y height is less than output width, top is less than output height and bottom is greater than output height. There is the problem. I think I may have just... Don't speak too soon. I also have to solve the problem with the first and last pixels, and I actually think I'm going to approach it slightly differently to the way that I did. In fact, I'm going to approach the little loop that draws the line slightly differently, I think. Okay, show me what you got. Index out of range. Now look, okay, line end is 10. That is not correct, is it? If the line end is 10, that is going to be out of range. Let's have a little look again. How is it that when something crosses the bottom, yeah, I think this should be -1, but then, funnily enough, I think this should be -1. And I'm a bit kind of baffled that it's not. And up here, yeah, it is -1. If it crosses the right, yeah, it's -1, and I'm going to make this -1 as well. Okay, and again. Okay. That is correct. That is correct. That is more or less correct. Yeah. Yeah. 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah. Yeah. I'm starting to slightly relax about this. Oops. Can I draw right down into this corner? That kind of gives me a little jolt of tension to draw right down into that corner, because I know it's the end of the array. Okay, I can hardly believe it. But it really looks like... Oh, look at that. Okay, well, that is not correct. Line start 0. What went different there? That's correct. That came out correct. This came out correct. That came out wrong. Why? Oh, that is very difficult. Because it's coming along x still. dy has become 0.43. So yeah, it would go along here if that was what it thinks dy is. How did it come to that conclusion? Oh dear, okay. What happens if I do this? All of those seriously are impossible for you to get right. You ever gonna get one right again? Actually, I'm starting to slightly relax. Not relax here. There, that one is correct. Well done, me. Okay. Let's swap these around. And it got it right. Okay. Problem. A problem. This will now be right. That's right. What was the other one that was wrong? Something like this. That's right. That's right. That's right. And this is wrong. Okay, so this start-end thing is correct. Here it did it right. God, a slightly annoying thing is I've got no way of knowing which of these is the start and which of these is the end. I don't think. So I can't figure out which. Can't figure out which way round it gets it right. But let me have a look at this. 15 minutes, not bad. Okay, so that's a problem. One way round it gets it right, one way round it gets it wrong. Let me think for a moment. What OLEX, well, OLE, so to speak, and OLS, they're the start and the end of the line as it's determined on screen. In that situation, the line's coming on the left-hand side. That situation of it coming on the left-hand side is this one. I'm saying SX, SY. I wonder if this is a problem. At this moment, dy dx, yeah, that is the line. Like, that's the segment, because the dy dx is based on cx px, or rather, the d difference vector is based on the current vector and the previous vector. Vector, yeah. So the gradient is based on the difference in the actual line, the segment, not the line that's to be plotted to the display, the output. Now, but my understanding is that that should still mean y at x0 is that. That is the c value, isn't it? Y equals mx plus c. But in this case here, I'm figuring out c. Y is 0, so 0 equals mx plus y. So subtracting y from both sides, yeah, negative y equals mx mx gradient times cx minus cy. I have a feeling that's not right. So 0 equals grad times x plus y at x0. So minus y at x0 equals grad times x. So why am I doing cx minus cy? Oh, I need a... I did figure this out before as well, didn't I? I'm maybe just making a total blunder here. Because cx minus cy is a thing that just doesn't seem to make any sense at all to me. I don't know why I've written that. It's like what would seem to make more sense is just grad times cx, but that's not sensible either. That gives me sorry, that thing still crashed. Actually, it's x at 0. I want y. I'm just being such an idiot all the time. No, hang on. No, that... want the value of y when x is 0. So I subtract. Did I just get this totally wrong? And I thought this through before and now I've just forgotten it again. It's crazy how, like, through never quite learning it in the first place and never really using it very much afterwards, the maths just goes. I know the gradient. I know an xy position. I want to know y at x0. And to me, the y at x0 is c. That's my memory of it. Because of course it is c. How did I figure this out before? I somehow decided to myself that y at x0 was c, but then I'm using y at x0 here, here, I'm using it here and here. So if I'm figuring this out wrong, how on earth have I ever got things right afterwards? I'm going to have to think about it again for a moment. I'm just going to have to accept the fact that I have unremembered this and that my scribbles here aren't much use. No, it's not 0. The only thing I know is I don't know C. Okay, right. I have to find C using my two knowns. So I have cy equals grad times cx plus c. Okay, right. Subtract c from both sides. I minus c equals g times c x. Okay, I see how I got it. Then subtract. Is that even alright? Yeah, I guess so. So c equals minus, yeah, okay. I was not insane. I did the sum correctly. I'm surprised, but I did. Unless it needed an extra bracket like that, which maybe it did. I doubt it for some reason. So that was a great big diversion as I relearned what I'd just taught myself. No surprise I had to relearn it, so I just remembered how to do that, and then it's not like I did a load of examples. Okay. Well, I suppose I can do this. Oh god, I don't want to do that. Well, yeah, I can. New. Yes. At least now I know the start is here and the end is here. And I can make this 10. And I can make this 10. And I can get hold of this and do this. And I can switch this on. And I can get in here. And once again I can count a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So to here. I think that was it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So I can sort of hopefully be able to see which end causes a problem. Now it seems weird, but I'm going to quit because that's a quick way to make sure that when if it crashes when it comes back, it'll be in this setup. With the start off the left. So this should be fine. In fact, I get nothing. Because of this. Ugh, go away. Gradient, static, save. That worked. Static, save. That worked. With the start of the left, it worked. Static, save. With the start of the right, it didn't work. With the start of the right, it didn't work. This is quite difficult because, as far as I was aware, by the time I was down at the bit to figure out doing XDY, yeah, I'm doing it with the OL start and end. So like if I was up here, anyway, that's irrelevant. And what was it said? Yeah, going along X, so it's always getting that bit right. And I am sure start X, yeah, start X 0, start Y 1, end X 2, end Y 3. Don't see how that can be causing any problem. Really just don't. It's just, it's coming, it must be coming in here. And it's, I suppose it must be going out here. If, oh, that is greater than that and less than that, and left is less than that, and right is greater than that. So all that comes out true, and that seems to apply. Y at x width equals gradient times cx. Is that right? That's not really right, is it? That's gradient times, is it not? Gradient times output height, or output width. Here I'm doing output height to check the bottom. Oh, another little thing. I think that that is a thing. I don't know if that's going to be the thing that solves this problem, but that is a problem. Let me think for a second though. Oh. Well, okay. Let's just go for it. And that's me just getting to time. Well, I feel like I'm making progress. I'm still pretty anxious about bits of this, and I still need to sort the first and last pixels, and I still need to... Okay, show me what you got. That's correct. Well, more or less looks it. That is also correct. Shift this one on. That looks correct. Shift this one on. That looks correct. Change the order of it. Looks fairly correct. Change which aspect of the line drawing routine it's using. Still looks right. Force it to use that aspect of the line drawing routine in the other direction, and it still looks right. What about off the bottom? In one direction with one routine? Looks right. In the other direction with that routine? Looks right. In one direction with the other routine? Appears to be more or less right. These are quick checks. Apart from anything, I'm making sure it's not crashing it. Other direction with that routine? That's a bit extreme looking to me. 2 there, yeah, I guess, but yeah, I don't know, it's pretty dodgy, that. But again, this is a very low resolution to be doing this simple version of line thing in, so I shouldn't really prejudge it, I don't think, until I see it. I swear, if this farts out an array, and look at that, see, that's as a result of coming to an integer, I think. Because really, that is up there. That just doesn't look right. And in fact, that's not right. Look at that. Yeah, no, that's not right, friend. It's not right. Man. Okay, well, maybe it's not to height to -1. At some point I'm doing a height -1. And also, okay, well, that's not bad, it's coming along. But I am going to have to call it a video there. Have a little think about the next move. One thing I've got doubts about is whether or not this is less than or equal to, and less than or equal to, as opposed to less than. I think it probably does have to be less than, but... And also, that... Does that make sense? Or does it make sense that it should be like this, -1? No, that's y at x. No, yeah, I'm doing that bit right. Not this one, though. yeah, sorry, that's that one, which I have to be doing right, which I am. These ones, don't know. Okay, well, I will try and sort it out next time.